Hello everyone, I'm Basim and today I'll be presenting about corrosion. I'll speak about what's the corrosion, what are its harmful effects, what are its types, how to reduce it, what future technologies can do to reduce it. Corrosion is a gradual natural process. It's a chemical process that occurs in materials and weakens them. It can be described as an electrochemical process. The most common form is the rust of iron or steel, where iron reacts with oxygen in the presence of water in the form iron oxide. As you see, that's an iron, and that's the diagram is an example to know how is that working. That is the iron as a symbol, and there's the oxygen and water is here H2O. When it reacts, we'll have the iron oxide Fe2O3 or the rust. And now we'll speak about what's the main harmful effects of the corrosion. First one, the structure damage. Corrosion affects structure, making them weak, brittle, and unable to withstand leaks. Second one, reduced lifespan of materials. All materials have a limited lifespan, and when they become corroded, this lifespan will be greatly reduced. And the third one, increased maintenance cost. As we know, if a material becomes corroded, it must be replaced or repaired, and that process requires a lot of money, thus leading to significant losses. Now, as we see, there are many types of corrosion, and we will talk about the types of corrosion, of course. There are 6 types of corrosion, and we'll discuss them one by one in this presentation. Well, now we'll speak about uniform corrosion, and is the first type of corrosion, which is occurring in the uniform manner across the inner surface of the material. As can be seen in the following figure, corrosion occurs in all areas or across the inner surface of the material. One of the most common causes of the type of corrosion is acid rain, because its effects in all of the cross-sectional area of the surface. The second type of corrosion is galvanic corrosion, which occurs when two materials, one acting as the anode and the other one as the cathode, are placed together in an electrically conductive solution, also known as an electrolyte solution. One material loses electrons while the other one gains them, resulting in a type of corrosion in the material that loses electrons. The third type of corrosion is pitting corrosion. This type of corrosion is known to be the most dangerous because it dentrusts the material, thus leading to a significant weakness of the material's strength and durability. The fourth type of corrosion is crevice corrosion. This type of corrosion occurs between closed surfaces or in narrow spaces. It's caused by the difference in the percentage of oxygen in the air between open air and narrow spaces. Its effect in the joints of the surface, and that make it weakness and reduce its adaptability. The fifth type is truss corrosion or cracking. This type of corrosion occurs in surface subjected to tension. For example, ropes used in support spreads. This type of corrosion occurs due to an increase in the surface area exposed to oxygen and a decrease in the distance between atoms. The sixth type of corrosion is intergranular corrosion. This type of corrosion is a major problem because it is not visible in the naked eye, and specialized equipment is required to detect it. It occurs between the layers that make up the material, making it extremely brittle, but it's not obvious to the naked eye. Now that we've discussed the different types of corrosion, we'll talk about ways to reduce its effects or protect against it. The first method we'll discuss is multi-layers projection. The main idea is apply several layers of their materials to be protected. These layers are less expensive, less susceptible to corrosion, and can be replaced if damaged. Examples of materials used are shown in the diagram. The medium layer is usually made of plastic or rubber, which has a medium thickness, while the top layer, which is thin, is made of plastic. Then, this process applies multi-layers of projection to the original material. This provides some projection. It's a good method because it's inexpensive and any damage can be easily repaired. Now we'll talk about the other ways to protect a material from corrosion. The first method is to apply a coating to the material. This coating is corrosion resistance, and even if it's cheap to use, we cover the material with it. The second type is to use non-corrosive material or non-corrosive alloys, as these materials have the ability to resist corrosion or not corrosion at all, such as nickel plating or non-corrosive sheets. The third method, and it's very useful, is to apply a cathode material. This method works by placing a material other than the material we want to project from corrosion. This material we'll place is a reactive material, as the reaction occurring in it's faster than the material we want to project. An example of this is zinc alloys, and it is connecting to the material we want to be projected by means of wire or a conductive material. When the exchange process occurring between the anode and cathode of the original material, it does not take the electron from the original material, but rather it takes it from the material placed to project. Thus, the material placed to project is damaged, while the material to be projected remains intact. The fourth type of projection method is regulating the environment in which the materials is placed, where humidity, air, acidity, and the type of fracture affecting the materials are monitoring and reducing the the effects of corrosion. Now we'll discuss the methods used to detect corrosion. First, the NDT method, which works by sending waves or X-ray to detect areas of corrosion. The second method is placing sensor in areas prone to corrosion and sending notifications via the internet. The third method is using remote control devices to inspect area in hazard and dangerous locations, such as using drones. And thank you for your listening.